lambda or lambda expression. So lambda is to simply put, implementation of functional interface. Okay, so functional interface means that if we have only one abstract method declared in such interface, then that interface is called functional interface. So that if it's an interface is functional interface, we can use lambda to represent it or to implement it. Okay, so for instance, the comparator, runnable, callable, and we have function, we have supplier, we have a predicate. Okay, so consumer, those are all functional interfaces. Okay, so let's see if we look at the runnable interface. Runnable. Okay, and here. So the annotation here is to indicate, to mark it as a functional interface, but this is more important. So we have only one abstract method. Okay, so this is the runnable interface, and also callable. Okay, so in the multi-threading, we talk about callable interface. This one is also functional interface, and also we have a comparator. Okay, so comparator here is also a functional interface, even though comparator is very complicated. Right, so this interface has a lot of default method, but default method has a body, so we don't treat them as abstract method. So only in here we have only one abstract method, which is the compare method. Okay, so this one. All right, so no matter what, we can also create our own functional interface. Okay, just I create an interface called my interface, for example. And if I have only one method, okay, it's called a method, for example, declared here. Okay, so then this function, this interface now is a functional interface. Okay, we can put this functional interface annotation above it to just make it more clear. But if I have two, okay, if I have two method declared, then in this case it will tell you that, okay, you cannot do this because it's not a functional interface. You cannot put this annotation here. All right, and if I remove it, then this is a normal interface. Okay, it's not a functional interface. If I remove this one, okay, so then now it makes a functional interface. So in order to implement a functional interface, you have to provide the only one implementation for this only one abstract, okay, method. How to do that? Okay, so simply we can just my interface are now gonna implement a implementation object, right? So the expression look like this: a curly brace, a parenthesis, and then curly brace, okay, and done. Okay, but it give us errors, right? Because this error is indicating this functional interface is not an implementation of this interface, because this lambda, okay, doesn't meet the requirement of this functional interface. What the requirement? The requirement is inside this functional interface, we need to implement this method. This method takes no parameter, returns an integer. But your lambda, okay, so this is the input parameters, this is the return. You didn't return anything. Okay, so in this case, we can return anything, like return 1, for example. Okay, and then this return 1 is a return. Now it works, right? So then this is gonna be an object of my interface. Okay, so here, right? So simplified. Otherwise, we have to do a lot of work, right? My interface, let's see, I2 equal to new my interface, and then we have to implement the code from here, right? So there's a lot of lines code to do. But with lambda, we can just use one line of code. Okay, and to simplify, okay, to simplify the lambda, if you have only one statement, and you can just simply put the return value here without write the return. So, and also you don't need the curly brace. Okay, so that I can put 1 there. Okay, that is also fine, because this is the only return, only value, only statement. So we can make it simplified to this one. Okay, and another example is the runnable interface, right? So if I want to create a runnable, okay, in the runnable interface, it has a run method. Run takes nothing, return a void. So takes nothing, right? And the body return nothing. Okay, so you cannot just skip anything here. You have to put something here. Okay, if you don't put anything, let's say I put 1, okay, it doesn't work because it's not returning 1. But if I put an empty body here, okay, then it works, because this is just empty, nothing there. Okay, so in here you can just do whatever you want. I can just print out something, okay, or I can just do some operations because this is the runnable body, right? Runnable interface implementation. But you don't need to return anything. If you put a return, okay, then it will tell you it doesn't make sense because this runnable, it doesn't return anything. So now you don't have to return anything here. Okay, so this is the runnable interface. Now let's look at the comparator. Okay, comparator, and it's compare something. So let's just compare string. Okay, and then we just call it C comparator, and equal to. Okay, so parameter and implementation. Parameter, what it takes. Okay, so go to comparator interface. We find the only abstract method, which is the compare method. Okay, where is it? Here. Okay, so now you can see it takes two objects. Okay, O1, O2 returns an integer. So here in the Lambda, we need to follow the same pattern. It takes two objects. Okay, O1 and O2. But for here, we don't need to write O1 and O2. Even though we can use any name. We can use A, B. Okay, we can use I, J. Okay, whatever you choose. Okay, this I is already used, so you cannot use I anymore. You can just use A, for example, A and B. Okay, and also those two input, okay, should be the same value as this one. This is a generic type comparator, right? T. So T is O1 and O2. Okay, but in this case, do we have to write here like string A and string B? Okay, so we can do that. Right, that's more clear, right? It takes two string A and B, and then we're gonna compare those two, like see with this A dot length minus B dot length. This is our comparison. Okay, this is our compare algorithm. Right, so we just return A length minus B length. So this is our algorithm. Okay, because it returns an integer, right? So the compare method. Okay, here it returns an integer. So no matter which integer you return, you can return 1. Okay, that's still fine, even though it doesn't make much sense, but it is legal. Okay, but again, to simplify, we can remove the string. We don't need a string because Java can imply what type it is. Okay, A and B. Okay, here, and also because it has only one line of code, right? So then we can just make A dot length minus B dot length if we want. We can just do it, simplify it like this. Okay. So this is the comparator. This is the Lambda. Okay, so you have to match the input parameter of this only abstract method, and also you have to match the return type. Okay, so that's the only two requirement of the functional interface. Okay, so now a test. Let's see if we have a predicate. Okay, so a predicate, you look at it, and it has only one abstract method declared here, so it doesn't have body. It takes an object T, returns a boolean. Okay, so how can you write an implementation of this? Okay, how you write the Lambda? Right, it takes a T, return boolean. Okay, so predicate, the type is T. So predicate string. Right, let's say P R P S. Okay, and then use Lambda. Okay, it takes a T, right? So it takes the op T. T is the string, right? So this is gonna be a string, and then it returns a boolean. So it will return true or false, right? So simply you can just write here true. Okay, or you can have a check, right? If you want to have a check, then you need a curly brace to wrap the body. And you say that if string dot start with, for example, A, okay, and then you return true, okay, you return false or return true, okay, or you directly return string dot start with A, right? So that is simpler, easier. Okay, otherwise you have to return false. Okay, for example here. Okay, so to simplify, return string dot start with A. Okay, and then simplify it to return statement like this. Remove the return. Okay, remove the curly brace. Okay, so then this is a predicate that it takes a string and check if it starts with A or not. All right, so this is the implementation of the predicate. Okay, thank you. This is Lambda.